Student, how are you? Today we are going to learn about the goal of operating system scheduling algorithms. What is scheduler try to achieve? The general goal of the scheduling. Some of the general goals of scheduling are fairness, efficiency, response time, turnaround time, and throughput. If you say one of the goal of a scheduler is fairness, mean that a scheduler makes sure that each process get its fair share of the CPU. Means no other process can suffer indefinite postpone or delay. That means each process has the ability to access the resources of CPU. Not giving equal or unequal time is not fair. That means resources of the computer should be shared equally. That is the goal of scheduling. The other goal of scheduling is efficiency. When you say the scheduler should be efficient, it should keep the system busy 100% of the time when possible. If the CPU and all the input-output device can be kept running all the time here, more work gets done per second than if some components are idle. That means the CPU should be busy and busy so that more works should be accomplished. That is the goal of scheduling. Yes, should CPU even 1 second should not be idle. The other characteristics or goal of CPU is the response time. The response time of the scheduler should be minimal. Means the scheduler should minimize the response time for interactive users. Yes. If the response time is high, there is high waiting, long waiting. That means unfair waiting is there. So in order to avoid this, the scheduler should minimize the response time for interactive users. The other one is turnaround time. Turnaround time. The goal of the scheduler should minimize the time batch users must wait for or not executing the process. So turnaround time is equals to CPU time plus waiting time or burst time plus waiting time. Therefore, the turnaround time of the scheduler should be minimal as much as possible. So turnaround time should be minimal, and in order to calculate the turnaround time of a scheduler, it is equals to CPU time plus waiting time or burst time plus waiting time. This is the formula how to manipulate the turnaround time. The other goal of CPU is in order to maximize the throughput. Maximize throughput. The scheduler should maximize the number of jobs processed per unit time. Throughput means the number of jobs processed or executed per unit time. Here we can classify the scheduling as primitive and non-primitive scheduling. A scheduler algorithm can be divided into two categories with respect to how they deal with interrupts. Based on interrupts, the scheduling algorithm divided into two: primitive scheduling and non-primitive scheduling. When you see the non-primitive scheduling, a scheduler discipline in non-primitive, if once a process has been given the CPU cannot be taken away from that process until the assigned process completes its execution. That means if one CPU or if one processor accessing a CPU at that instant of time, the other processes are stored in waiting lists, and the already accessing CPU is do its own jobs until completion. So non-primitive scheduling is also called run to completion. If a given process accessing a CPU it runs until the end of the execution. That means in non-primitive scheduling, there is no interrupts. Following are some of the characteristics of these kinds of scheduling. In non-primitive system, short jobs are made to wait by longer jobs. Yes, means if longer jobs are executed or trying to access the CPU first, then shorter jobs are still in waiting lists. Means in non-primitive system also the response time are more predictable. That means the maximum response time or the maximum waiting time is there, because incoming high priority jobs cannot interrupt the already executing processes. So in non-primitive scheduling, the scheduler should execute jobs in the following two situations. The first one, when a process switches from running state to waiting state, and when a process terminates the execution. In the case of non-primitive scheduling, the strategy of allowing processes that are logically running to be temporarily suspended is called primitive scheduling. Also, it is the contrast to run to completion methods, that's non-primitive scheduling. In non-primitive scheduling, each and every process works on the principles of run to completion, whereas primitive scheduling works not in run to completion techniques. Rather, processes are interrupted based on their priority. Okay, so there are few scheduling algorithms out there. The first one is first come first served scheduling algorithm, or FCFS, shortest job first, SJF, shortest remaining time, SRT, round robin scheduling, that is RR scheduling or priority scheduling. This scheduling should be discussed in detail. Okay, first come first served or FCFS scheduling algorithm. It is also called first in first out or FIFO, run to completion or run until done. That means these kinds of scheduling algorithms are non-primitive scheduling algorithm because it is also known as run to completion. This scheduling algorithm is the characteristics of non-primitive scheduling algorithm. So the first come first served scheduling algorithm is the simplest scheduling algorithm as compared to others. Processes are dispatched according to their arrival time on the ready queue. If a given process comes first, it's trying to access the CPU and works until the end of doing tasks, or runs on the principles of run to completion. So being an primitive discipline, once a process gets a CPU, it runs to completion. So the first come first served scheduling algorithm is fair in the formal sense or human sense of fairness, but it's unfair in the sense that longer jobs make shorter jobs wait long period. So this scheme is not useful in scheduling interactive users because it cannot guarantee good response time. The code for first come first served scheduling algorithm is simple to write and understand, and the drawback is the average time is often long and long. Okay, let me show you a simple examples that illustrate first come first served scheduling algorithm. For example, here there are three processes, P1, P2 and P3, and each process has its own burst time. For example, P1 has 24, P2 has 3, P3 has 3. So if these all are given, the process and the burst time is given, we can calculate the average waiting time, the average response time, average turnaround time, the throughput also. How? In order to illustrate or find these all required things, first we have to design a Gantt chart. A Gantt chart is a representation of such algorithms in such a way. So in order to illustrate a Gantt chart. How many processes you have? There are three processes, P1, P2, and P3. P1 comes first, and then P2 comes second, P3 comes third. So let's say P1 comes first, means at interval 0 or time 0, and it runs until completion up to 24 time. Burst time is 24, that means 0 up to 24 is assigned for P1, and P2 has 3, that means from 24 plus 3, that is 27, and P3 is required to complete its task up to 23 plus 27 plus 3, that is 30. This is, so the Gantt chart is drawing like this. In order to find the average waiting time of each processes, that is P1, P2, and P3, we can manipulate like this. For example, the average waiting time of process. In order to get the average waiting time of all the process, that is P1 and P2, P3, first we have to find the average waiting time of each processes. For example, to find the average waiting time of process 1 comes at 0, and this process P1 comes in front of P1, P2, and P3. Therefore, this P1 has not get any delay. That means no waiting time. So the waiting time of process 1 is 0. In order to find the waiting time of P2, P2 arrives after P1. So P1 completes up to 24. Burst time of P1 is 24. So how many time it waits? That is 24. The average waiting time of P2 is 24 and P3 is 27, because 24 plus this is 3. 24 plus 3, that is 27. So this is average waiting time of P1 is 0, average waiting time of P2 is 24, and average waiting time of waiting time of P1 is 0, waiting time of P2 is 0, waiting time of P3 is 27. This is 24, this is 27. Let me add it. 0 to 0 plus 24 plus 27 over 3. That is, we can calculate like this. That means 0 plus, okay, I think 50, 0 plus 24 plus 27, which is equals to 51. 51 divided by, in order to find the average waiting time, that is 3. How many processes have? 3. So divide by 3. The answer is 17. Look here. The average response time is also similar. And the average turnaround time means 24 plus 27 plus 30. That is the average turnaround time. And the throughput is also calculated by using the formula. Throughput is equals to number of process over total time. That is number of process 3. Total time of each process 30. So 3 over 30 is 0.1. This is the formula. Just we can give main examples of this scheduling algorithm for today's session. It's enough for today. Thank you. Don't forget to like, share, and subscribe this video.